can see on the screen, there is a full title of the project, Towards Energy Transition and Climate Neutrality in the Baltic Sea region municipalities, but for short, we call it CommitClimate. Then again, very shortly about our project. It's founded by Inter-Baltic Sea Region Program of the European Union. We have partners, as you see on the map, from Sweden, Estonia, Latvia, and Poland. Our main objective is to strengthen local authorities' capacity to address complex issue of energy transition. And during this project, we are developing a computer-based interactive tool for carbon footprint calculation and scenario modeling. Of course, we have another priorities such as strengthen communication and interaction with local stakeholders, for example. But today, we'll explore why energy efficiency is a cornerstone of carbon neutral cities. First of all, at its core, energy efficiency means using less energy to provide the same services. For example, better insulation allows buildings to stay warm while consuming less heating energy. Far from being a niche topic, energy efficiency is actually one of the most powerful tools for cutting CO2 emissions. For example, according to the 2021 report of International Energy Agency, efficiency improvements could provide over 40% of the greenhouse gas reductions needed globally by 2040 to meet Paris Agreement targets. And now about the municipalities and cities context, because cities actually play a crucial role in achieving these goals. Buildings alone account for 40% of Europe's total energy use and around 36% of CO2 emissions. But yet, many municipalities still rely on outdated infrastructure that wastes energy. And by prioritizing efficiency, cities may drastically cut emissions while improving public services and reducing costs. This is where the sustainable energy and climate action plans come in, because they help municipalities to reduce emissions, improve energy security, and build resilience. But where should cities begin? And the answer is simple. It's today's topic, with energy efficiency, because the cleanest, the cheapest energy is the energy that we actually don't use. Which is why the European Union promotes the efficiency first principle, which means that before investing in new energy productions, cities should first eliminate waste and optimize existing resources. Sorry. And it isn't just a theory, it's already happening across Europe. The Covenant of Mayors is a network of over 11,000 cities. They had made energy efficiency a key pillar of municipal climate action. And here I put results which are from already 2017. So now we assume that they get even bigger. Reductions of CO2 emissions and drop in energy consumption. And this was largely met by the energy efficiency initiatives. And today I'm hoping to hear more success stories from our partners. So we will hear about that shortly, I believe. But why does every sustainable energy and climate action plans have to prioritize energy efficiency? Simple, because it makes climate goals more achievable. Because imagine trying to power a city with 100% renewable energy, but if the energy use remains high, it's much harder and much more expensive. But if we reduce energy demand first, the transition is faster, cheaper, more sustainable. There are some also additional benefits, such as we are saving money, we improve air quality. By that, we are also influencing the health of our citizens. And of course, we can create more jobs by doing so. So now what municipalities can do? They have, firstly, they have to make efficiency the foundation of every action plan, invest in building retrofits, LED street lights, and efficient transport, for example. Secondly, it's to engage businesses and citizens, because efficiency succeeds when the whole community participates. And thirdly, it's to track and promote results, showing that progress, it attracts funding and helps scale solutions. So in short, if we want carbon neutral cities, energy efficiency isn't optional, it's essential.
Today, this topic is about empowering youth for the energy efficiency. And as Alina already said, all the cities around the Baltic Sea region, and not only around the Baltic Sea, but also in Europe, are fighting for reducing our carbon footprint and also for making our infrastructure, our buildings more energy efficient. Latvia, we are in Riga capital. We are the largest city with more than 600,000 inhabitants. And if we look at the metropolitan area, then it's even bigger. It's approximately 1 million inhabitants. So the impact of Riga towards countries' carbon footprint is very significant, and the housing sector and heating sector are the major divisions, the major directions where we are focusing in order to make them more energy efficient. We have quite a large apartment house market. Our historical buildings from the Soviet time, especially approximately 6,000 apartment buildings that need deep renovation. And for that, we need certainly support of our citizens and inhabitants of these multi-apartment buildings. Riga city already has done a lot in order to engage our citizens in decision making and persuading that energy efficiency is one of the main activities. We have, for example, Geo Riga open portal where any citizen can come and see what his building is, how energy efficient it is, and it makes more easier for us to persuade citizens to invest in their houses. And we have, as already Alina told, we have a quite ambition sustainable energy and climate action plan for our city, where we have to reduce energy consumption of municipal buildings significantly, and also we have to reduce CO2 emissions for the infrastructure. What have we done already in 2021, sorry, we set up integrated monitoring system of our municipal buildings, where all the libraries, all the schools, kindergartens were connected in one unified energy management system. And based on this, we can see in a centralized way comparative data on consumption of heat, electricity, water, and we see the trends, and we see what and where we could increase the efficiency measures. Of course, we also have invested heavily in our municipal sector, in schools in particular. We have had in a renovation of their heating systems, the general systems, so that the schools are prepared for much higher savings in energy consumption. But one of the challenges, the daily challenges, what we face is how to ensure effective daily energy saving decisions. The masters, the directors of schools, they are responsible for the educational process, not for the management of real estate. This is kept in separate infrastructure departments, in financial, the ownership department of our municipality. And so sometimes we see that the schoolmasters, the teachers are not so much interested in saving the energy, despite they have already quite up-to-date modern energy systems in place in schools. So one of the solutions what we have found is that we have to invite youth to take part in the decision making in daily life, to empower also existing eco movements in schools with additional knowledge and with additional tools, how in a daily on a daily basis the schools and groups of classes can save energy, and to make also this saving interesting, attractive, and so for the pupil to be proud of. So this year, last year in October, we announced a competition for interested youth groups to take part in so-called Riga School Climate Days. This is an effort of several municipal organizations, including Riga Energy Agency, but also Riga Educational Department, in cooperation with Riga Technical University, other interested parties, to have a competition for different groups of pupil in schools. And besides the task of energy consumption reductions in municipal buildings, we also would like to improve students' knowledge of environmental and climate issues, support already existent climate-friendly youth initiatives, and through children, we hope that we can create awareness on energy efficiency also in families. As I was telling about apartment buildings, I very much hope that the activities that children do at school could be interesting also for families, and thus we can make a change in habits of in a wider Riga society. It's not only about energy efficiency and then heat consumption, but it's also about other environmental issues like circular economy principles, CO2 reduction, use of different materials, act in an environmentally friendly way in the daily life. So this competition is organized in two parts. The first part takes place until April. It's internal school competitions where different groups of pupil can create their teams. Also, the classes can compete with each other. Uh, I know that there are several schools that organize internal hackathons at school. They analyze energy consumption. They propose different measures. They have to prepare kind of a project, how they are seeing, how they make their school more environmentally friendly, how do they create less CO2 emissions. And then on the second part, we will organize a final event called Climate Festival on the 4th of April, where the best groups can present their projects. We also collect data about energy savings in each of the participating schools, and the best groups are awarded. Up until now, I know that there are 26 schools that are taking place in this competition, and one of the activity within this competition is that schools can invite energy detective. We, Riga Energy Agency, we provide an expert, young guy, usually with the skills of energy advisor, to go to the school and to tell interested groups of classes, groups of pupil, what are the most effective energy saving measures, how these young guys and girls can in a daily life save energy, save water, save electricity, and also advise on particular issues that come into minds of pupil when they prepare their projects. This is they can book this visit online on our website, and so far 13 school visits have already taken place with a quite wide range of age groups. We've seen the first classes. We have participated also in older classes, the high school, and it's of course quite a challenge also to tell complex issues for in a simple way to the younger classes, so that they understand that the issue and they can prepare their own project. There have been more than 20 inquiries apart from the school visits, and we are very happy to support schools in this process. And it's not only the energy detective, the person that goes to schools. We participate in different events where younger generation come together and discuss different environmental related issues. This is one example of organizing a climate day in December last year, where also our director and our experts participated in discussion with the younger generation and telling and discussing how relevant are the energy savings in school. There is also a special website created for teachers with methodologic material, with also the carbon footprint calculator from our project CommitClimate, and also other materials, teaching materials. So every person can visit this website and see what materials and what approaches can be used for the preparation, for the discussion, for other activities, for the benefit of this competition. And I very much hope that in April we will see the final outcome, the climate festival, and we will see what will be the results of this competition. And already we can say that the responses so far have been very positive. So we very much hope that this competition will continue also next years. So this is my presentation, and I'm very happy to answer the questions.
I was invited to speak about the neighborhood-based and prefabricated renovation projects in Estonia. And I'm from Tallinn University of Technology. My main research fields are building physics and renovation of buildings, energy performance, indoor climate, and building envelope structures. And first, some words about apartment building stock in Estonia. This is most typical residential building type because more than 70% of population lives in apartment buildings. And if we consider apartment buildings that are already renovated and that will be left out of use in the near future, about 14,000 apartment buildings need to be renovated. These buildings are mainly constructed during 50s and the 90s last century. Typically, they are brick or concrete large panel apartment buildings, and they were constructed during a very short time period. And if we see the construction wave during 60s and 80s last century, and if we add typical service life, design service life, then we can see that already today older apartment buildings are in situation where design service life is over, and we have to renovate them anyway, in addition to energy performance targets. And this brings us to from construction wave to renovation wave. And we can see that during the year when we made in Estonia the Estonian long-term building renovation strategy, then forecast is that the renovation volume will increase about 5 times. Apartment buildings which are in the best situations, because there has been about 15-year development for technical solutions, for business models, and so on. We see increase about 3 times. But it is difficult to run 3 times quicker or to renovate 3 times more with the same technology. And we see that the industrial renovation is needed for renovation wave. If we look back more than 100 years ago, what happens in the car industry, then we can see the same street in New York, Easter morning, same time in year 19,000. Then we can just spot one car on that street. After the car industry took factory production, which is more efficient, which can decrease cost and so on. After more than 10 years, we can spot only one horse and mostly cars. This is not message that we have to drive today by cars, but this is message that if we want to increase the renovation volume, we have to go to the next step in industry revolution. And we have had many pilot projects in our university. All started with More Connect in 2014, 10 years ago. And then after that, we had the Drive Zero project. And today we have some more project where we develop the renovation with prefabricated insulation elements. What does it mean? We can see on this short video. It's from year 2017-18 when we renovated our first the pilot building. This is a university dormitory. It was constructed in 80s last century and was in condition that was really needed to be renovated. Insulation elements were like 3 meters per 10 meters and were produced in factory conditions, transported to the construction site. Windows were installed already to the element in factory conditions. And with this industrial technology, we can increase the quality of renovation and also speed of renovation. And when there is enough volume, we can also decrease the cost. Insulation elements are produced in factory conditions without rain or without any other weather problems. And the quality is much higher because there are qualified workers. This is the next pilot building where we renovated apartment building so that inhabitants live inside the apartment. They clean kitchen in the morning and in the evening after they returned from work and they started to live to continue the normal life. So 24 families in this apartment building lived inside the apartment during renovation, so they don't have to move out. We can see the installation of the element also from inside. To the southern side, balconies were added so that they have also possibility to go outside from the apartment level. Insulation elements are possible to put also to the roof. First, we constructed a timber frame and then we added insulation elements above it. And on this small attic, we have ducts for mechanical supply and exhaust ventilation with heat recovery. So together with insulating building, it's very important that we improve also indoor climate. So without good indoor climate, the renovation is not acceptable solution in Estonia. And about cost, this is cost overview about the second pilot project where we changed the energy performance certificate from level D to level A, which is the highest energy performance certificate level. It corresponds to the nearly zero energy building, and the cost for apartment building square meter was 500 euros per square meter, and this was in 2022. And on the southern side, we have new balconies and PV panels on the roof. And these PV panels produce as much electricity that the apartment building use on the annual level. So from electricity point of view, this is zero energy building. Today we are working with Soft Academy project, which includes 4 apartment buildings. So this is the next step next step in industrial renovation, because we need a larger volume. When the construction company knows that they have to renovate 4 buildings altogether, then they can get cheaper materials because volume is higher, and also the price will decrease, or at least should decrease, as we have seen in car industry. Another important topic in this project is to develop to local municipality renovation one-stop shop or service, so that local municipality can consult apartment building or detached house owners to become renovated. There are many topics that need to be solved. For example, when apartment building want to construct new balconies or staircases or elevators, then in some cases the border of the land is just some meters from building, and the target is to make some kind of legal order that it's allowed to construct this new staircase on the municipality land without any complex legal procedures, and the same with balconies. And another challenge is to develop to make procedure to simplify the design process. If we have typical buildings and if we have typical renovation solutions for building envelope insulation or ventilation, then we could get the building permit for renovation based on these typical solutions. The last part of my presentation is about the renovation strategy tool. Here we combine digitalization, Green Deal, and decarbonization target. And we are making next step on the industrial renovation from mass production of renovation for mass renovation to information technology. And let's take one example from Mustamäe district. We first define the area that we analyze. Then we will get information about the current energy use based on energy certificates which are in the building register. And then in Estonia, we have all buildings. We have a digital twin for more buildings. For example, if we have this aerial view, then we have geometry from all buildings. And based on this, we have also trees and other information from other nature available. And then we get building register information about area of the building and energy use of the building, and then we can develop renovation strategies not only for one building but for multiple buildings or for whole neighborhood. And then we can consider different restrictions. For example, is there any heritage buildings or monuments that cannot be renovated in the same way as typical buildings, or what is property value, or do we have any problems with water, and so on. And if we want to produce electricity on site by PV panels, then we have to consider also neighboring buildings And based on our analysis, we have shown that the current methodology that assume that there are no neighboring buildings or trees, then the real electricity production can be up to 1/3 smaller. Then the final solution can be optimized depending on different targets, depending on the money or depending on CO2 or other parameters. So this was a short overview, and I'm looking forward to your questions.